Good day, everyone. So I'm here to continue the nuclear chemistry. So the next aspect of nuclear chemistry is known as what? Nuclear energy. So what is nuclear energy? The nuclear energy is the energy released during the process of radio activities, or is the energy release during the process of nuclear reaction. If you could still remember in my previous class, we knew that I've explained the nuclear chemistry as the aspect of the chemistry that deal with the study of nuclear particle, or the reaction that involving proton and a neutron in the nucleus of atom, and the reaction is generally known as nuclear reaction. So the reaction that takes place in the nucleus of an atom, call it nuclear reaction. So, and I said the nuclear reaction can be grouped into four. We have radioactivities, we have radioactive decay, and we have atomic fission and atomic fusion. So the atomic fission and fission, we can also call it nuclear fusion and nuclear fission. So, and in the previous class, I've explained what we call radioactivities. I've explained the radioactive decay. The next aspect now under nuclear reaction that we are going to treat is nuclear fission and nuclear fusion. So let us now look at the nuclear energy. Nuclear energy. So this is the energy released when a radioactive isotope or any element emits radiation. Emit radiation. The energy released when radioactive isotope or element emits radiation is called nuclear energy. So and the nuclear energy can be derived majorly from it can be derived from nuclear reaction. Nuclear reaction, such as one, such as one, we have nuclear fusion, and we have nuclear fission. So the energy released in nuclear reaction, or the energy released when the radioactive element is being emit radiation, is called nuclear energy. So the nuclear energy can be derived from nuclear reaction, which is nuclear fission, and the nuclear fission. Let us look at what we call nuclear fusion. What is nuclear fusion? The nuclear fusion is the fusion of two or more lighter nuclei to form heavier nuclei with release of of energy. Okay, nuclear fusion is this occur when two or more lighter nuclei are found together to form heavier nuclei with release of energy. So when two or more lighter nuclei or smaller what nucleus, they come together to form the what the bigger nuclei, is called nuclear fusion. Look at the word fusion. Fusion means what? To what? To combine together. So when two or more smaller nucleus combine together to form the heavier nucleus, is called nuclear what? Fusion. This is the example of nuclear fusion. In case of we have what? One hydrogen of what? Of deuterium plus another hydrogen of what? Of tritium. So to give us what? This is tritium, deuterium, to give us what? New two atom number and helium plus what we call what? Neutron plus what? Energy. So this is what we call what? Nuclear what? Fusion. At this reactant site, the deuterium hydrogen and the tritium hydrogen, they fuse together to form helium and what? And neutron. Neutron is what? 0, 1 with release of what? Of energy. The energy released here in this nuclear what? Nuclear fission is called nuclear energy. The energy released in this what? Nuclear fusion is called what? Nuclear what? Nuclear energy. So this is what we call what? Nuclear what? Fusion. They combine together. Deuterium and tritium. Once again, they combine together to give us what? Helium of atomic number 2, mass number what? 4. Here we have 5. That's why we have what? Neutron here. This which release energy. Energy that released here is called what? Nuclear what? Energy. The next thing we did now is what? The application of nuclear what? Nuclear fusion. So what are the application of nuclear what? Fusion? Let's look at it now. Application of nuclear fission. Sorry, nuclear fusion. We are combining this time around. Nuclear what? Fusion. So this nuclear fusion has the two basic what? Application. Number one is used in what? In generation of electric what? Power. We can use what? Nuclear fusion to generate electric what? Electric power. This same nuclear fusion we can also use to what? To manufacture, is used to what? In a manufacture of what? Of hydrogen what? Hydrogen bomb. You can use nuclear fusion to what? In a manufacture of what? Facture of what? Hydrogen what? Bomb. So those are the what? The two applications or the basic or the common uses of what? Of nuclear what? Nuclear fusion. The next one is what? What we call what? nuclear fusion. We are done with fission. We have nuclear what? Nuclear fusion. So if the nuclear if the what the nuclear fission the nuclear fusion is the combine of two or more what lighter nuclei to give us what heavy nucleus and release of energy is what fusion we combine. This fish fusion, sorry, what is happening to me this morning? Here we have nuclear what fission. So the fission simply means what the breaking down of what the nucleus of heavy radioactive what elements or isotope into the what the smaller radioactive what isotope or element with release of what of energy. That is what we call what fission. In fission here we split heavy nucleus, but in fusion we combine the lighter what nucleus. Be like what and opposite. Here we combine. What happen here? We split. What in nuclear fission. You can say what this is the splitting thing of the nucleus of heavy radioactive isotope or what element into smaller nucleus. This is the splitting of what of nucleus of radioactive what element. Splitting of what of nucleus of radioactive element in the presence of neutron. In the what presence of what of neutron presence of what of neutron yes to release or to form where is the splitting of what the nucleus of every radioactive isotope or element in the presence of neutron to into smaller nucleus with release of energy. So like I said earlier that what the fission means what to split. Where fusion means what to combine. So here we want to split the nucleus of every radioactive element into the what the smaller radioactive what element in the presence of what of neutron to release what energy. Let's check the what the nuclear fusion. The nuclear fusion is very common in what let me say the breaking splitting of uranium. If you have what uranium 92235 uranium, you now bombard this uranium with what? With neutron. With neutron, it will now give you what? It will give us what? Uranium 236, and this uranium 92236, it will now later split to what? Beryllium and what? And krypton plus neutron. We now have what? Berry what? Ba, like this one is big. Let me say, we have uranium what? 92235, but bound with what? Neutron. This will give us what? Uranium 92236, isotope of what? Of this. And this is now later give us what? Beryllium plus what? Krypton. This is the beryllium, is what? Krypton plus 2 mole of what? Of neutron plus what? Energy. This is what we call what? Nuclear what? Nuclear fusion. Fission, splitting. This is the krypton plus what? 2 mole of what? Neutron plus what? Energy. And you have here, this is what we call what? Barium. This is what we call what? Krypton. This is what we call what? Neutron. This E is what? Energy. And this is what? Uranium. So the bombardment of what? We can see that this is a what? A uranium, a single element, split to the what? To the krypton and what? And beryllium, with release of what? Of energy. The energy release here is called what? It's called nuclear energy. So when we bombard what? Uranium with neutron, and the uranium is a what? Is an unstable radioactive isotope. So its nucleus now emits what? Radiation, and release what? Is split to beryllium and what? And krypton, with release of what? Of energy. That is what? Nuclear fission. The next one is what? Let us look at what? The application of what? Of nuclear fission. What is the application of nuclear fission? The application of nuclear fission. The first one we did is what? Nuclear what? Nuclear fusion. Abi? So the nuclear fission, the first application of it is what? It is used to generate electrical power. Is used to what? To generate what? Electrical power. And we can also use it to what? Use to manufacture or to produce what? To produce atomic bomb. Yes. Yeah. The nuclear fusion, yeah, is not for electric power, for generation of solar what? Solar power. So we use what? The nuclear fusion can generate what? Solar power, where what? Nuclear fission can generate electrical what? Electrical power. And it's also used to what? To produce atomic what? Atomic bomb. So that is the application of what? Nuclear fission. The next aspect now is what we call what? So it's not nuclear, it's chain. Chain what? Reaction. Yeah, chain reaction. Hello. We all know that what the fission is the splitting of what of heavier nucleus to the lighter nucleus. Or fission is what is the breaking down or splitting of nucleus of what of unstable, heavy, unstable radioactive element into the lighter one. That is what fission. By bombarding the what the heavier nucleus with what with neutron, abi, and it will give us what beryllium, krypton, and this with release of what of energy. And if this what reaction is what is not controlled, is dangerous. It can lead to the what we call what explosion. What we call what explode what explosion. The continuous action of what of this. And if this reaction is what is continuous, if the reaction is what is continuous or is continuous action of what of fission is what we call what chain reaction. The what continuous action of nuclear fusion lead to the what we call what chain what chain reaction. Therefore, what is chain reaction? So chain reaction can be defined. This can be what defined as a multiple flying action of nuclear fission. And that is what the multiplying action of what of nuclear fission. This can be defined as a what as a multiply action of what of nuclear what fiction. And if the reaction is not controlled for what? Control may be lead to explosion. So the continuous action of what of nuclear what fission is called chain reaction. Chain reaction is what is the continuous or the multiplying action of what of nuclear fission is called chain reaction. And if this reaction is not controlled, can lead to the what to the explosion. That's why I said the what is used to manufacture what atomic bomb. So how are we going to what to control what this what nuclear reaction, or how are we going to control the what the chain what reaction? We now have what some heading control of chain reaction. See, look at this chain reaction. It takes place in a device called nuclear reactor. Why do I call it nuclear what? Nuclear reactor. So nuclear reactor, nuclear reactor what? Reactor is a device, is a what? Is a device in which nuclear fission chain reaction take place with proper control. So what is a what? A nuclear reactor. Like I said, what? The continuous action of nuclear fission is called chain reaction. And this chain reaction, it takes place in a particular device called what? Nuclear what? Reactor. A device where what? Chain reaction of nuclear fission taking place with proper control is called what? Nuclear what? Nuclear reactor. So how are we going to what? To control the what? The nuclear what? Chain reaction. So to control this chain reaction, we need some what? We like this nuclear reaction. We have what we call what? It's comprised of what we call the moderator, carbon rod, neutron, and others. Let us look at what? How all those devices can what? Can control nuclear what? Nuclear nuclear fission chain what? Reaction. So this, you know how to do how this works. How are we going to control the chain reaction in nuclear reactors, Abi? So from there, let us look at what the component of what of nuclear reactor. It consists of the following. Number one, we have uranium rods. The uranium rod in nuclear reactor, it serves as fuel. And the next one we have there, we have graphite rods. Graphite rods and heavy water, which is what? And heavy water, yes, graphite and what? And heavy water, which serve as what? They serve as moderator. And the next one is we have coolant. An example of coolant here, we have CO2, we have H2O, we have nitrogen as coolant. They are the what? To reduce or to cool the what? To reduce or to cool excess heat in the what? In the nuclear what? Reactor. So the coolant that is what? That is cool, the reaction is what? We use CO2, water and nitrogen as what? As a coolant in a cooler reactor to reduce the what? The excess what? Excess heat. And the next one we have what we call boron rod. Boron rod. This boron rod is the one that is control the what? The amount of what? Of neutron in the what? In the nuclear what? Reactor is what is control the what? The amount of neutron in the reaction, or it is what? It is absorbed. The what? The neutron in the what? In the reaction. So the moderator are what? Heavy water and the what? Graphite. Uranium serve as what? As the fuel of the what? Of the reaction. The graphite and the heavy water, they moderate. They are moderators of the what? Reaction. Coolant is what? To reduce excess heat in the reaction. And then we have boron rod to control the what? The amount of what? Of neutron in the what? In the reaction. So that is what? All about what? The chain what? Chain reaction. And the next aspect that we are going to take now is what is the kinetics of radioactivities. What is kinetics of radioactivities? Or we can call it what? That is the next aspect where we are going to what? To derive the half-life formula and there's some calculation aspect of what? Of radioactivities, which is known as what? Nuclear chemistry. And then under it, we are going to know how to calculate what? The mass defect and the binding energy.